All right, hey guys, Miss G here. Hope you enjoyed your weekend. You got out there and got to see some sunshine, enjoy some storms, play some games, do some stuff with your family, whatever it is. Um, we're going to start our second week of remote learning. One thing that I did notice that we were missing in our class was our wacky days of the week or our wacky celebrations. So today is March 30th, Turkey Neck Soup Day. So if you have some turkey necks, I guess, hanging around, you can make a soup out of it to celebrate. This week we're going to start off with rigid transformations and then also talk about some shape characteristics. I noticed we needed some more work on rigid transformations after taking a look at your assignment from the end of last week. So this is just going to be a quick review of our rigid transformations. You can find this in chapter 1 in CPM starting at 1.2, and I believe it goes all the way to 1.2.6. So in case you want to take a look at that, when you know that I'll probably give you some definitions for some homework or whatever it is. Okay, so we have our three rigid transformations. We have reflection, which means we're going to flip. So if you take a look at the FL and reflections, you can think of that as being a flip. So that's when, you're looking in the mirror and you see your reflection. Your body is flipped around. Translation, I didn't write that one down yet, so let's go ahead and do that. That is known as a slide. So the SL in translation stands for slide. That means you're just moving the object around in any position, up, down, left, right, diagonal, whatever. And then rotation has the T in it, which stands for turn. So that's when you actually turn it, and we refer to a clock on that one because we have counterclockwise or clockwise rotations, and I'll get to that when I'm doing the examples. So the other important thing about transformations is you need to know which one's the image and the pre-image. Actually, the pre-image is the first one. So whatever we start with is going to be the pre-image, which is all of our yellow triangles, and then our blue triangles is going to be the image, what happens after we either flip, turn, or slide it. The second thing is that we always have labels on our vertices. So as you can see here, we have triangles ABC. When we flip it, we're going to have A prime, B prime, C prime. So remember, the A, B, and C pretty much stays the same. It's just in a new location. So that's why we write the primes. Kind of like when we're taking a look at slope and you remember the formulas being y2 minus y1. The same kind of y's, they're just in a different location. So it's a little kind of subscript type thing. All right, so for the example, tape here. For the pre-image of our reflection, and we're going to reflect it across a vertical line. Remember, it's reflected across any kind of line. I'm just using vertical line right now. I'm going to match this up. Nope. Oh, duh. Because it starts like this. Hello. All right, so we have our image in yellow. You can see that this triangle is the blue triangle is the exact same triangle as the yellow triangle. So I'm taking my triangle and I'm reflecting it across my line so it looks like this. Now what you should notice is that if this is the exact same triangle, which it is, I showed you in the beginning and I just flipped it over this line, that I'm just going to label this for you, that the distance from A to B is still the same for A prime, B prime. The measure of angle B is the same, A's are the same, and C's stay the same. So everything stays the same. The only thing that changes is the location on the grid. So since this is the exact same triangle, we've talked about this before, we know that these are congruent triangles. All right, taking a look at translation. I think translations is actually the easiest one because you just have to slide it, but they started off with reflection, so figured keep it the same. Translation is just when you slide the object. So you can either slide it to the right, slide it down, slide it at a diagonal, doesn't matter. Let's go ahead and just say we're sliding ours at a diagonal. So that means that our triangle stays like this. Oh, the tape's on the wrong side. And it now looks like this. So that means that the letters are in the same spot because we just slid it. Same thing if we would have gone up or down. Now, since this is in a diagonal, that means we moved in both an X direction and a Y direction, but it's still sliding to the new point. So again, this triangle is the exact same as this triangle. So all of the angle measures stayed the same. The lengths of the triangle stayed the same. The only thing that changed was the location noted by these prime marks. So these are going to have new X's and new Y's. If we would have slid it over here, then that means we only changed in the X direction. So all the Y values stayed the same, but the X's changed. It's still A prime, B prime, C prime. Hopefully you're noticing a pattern here. All right. And then finally, we have rotation, which is just turning. Sorry, I stepped out of the screen there for a little bit. So one thing that I do want to remind you is we talk about a clock when it comes to rotation. So you can either turn clockwise or counterclockwise. So if we're moving like this in rotation, that's normal for us. So we know that as clockwise. If we are going, oops, I'm drawing in the same way. If we are going like this, okay, that's going backwards. So that would be counterclockwise. Okay, so normal way is clockwise. The other way is counterclockwise. All right, I'm going to erase that real quick just so I have some room. I don't have the luxury of my giant whiteboards in my classroom. Luckily, my mom gave me this one, so shout out to my mom there. All right, so this one right here, we're always going to turn around some point. Okay, so what we started off with was the point of origin, meaning around 0, 0. This time, I'm just going to say that we're going to rotate it around point B. So since this vertex right here is angle B, it's going to be point B on our graph as well. So I'm going to rotate it around point B. So that means that B isn't going to change. Stays in the same spot. And I'm going to rotate it. Let's go clockwise. So as you can see here, we have our new triangle, and I'm going to write B prime for you as well, even though B stayed the same. But here we moved our triangle this way, which would be clockwise. So that's what a rotation looks like. So these are our 3 rigid transformations. Remember, rigid transformation means the outcome is congruent figures. So that means that your shape stays the exact same. So congruent, same size, same shape. So angle measures, if it started out a 30, 60, 90 triangle, it stays a 30, 60, 90 triangle. If all of the sides were 3, 4, 5, then those sides stay 3, 4, 5. Nothing changes at all, just where it was on the paper or your grid, wherever it was. So reflection, translation, and rotation. That's the thing that we're going to work on for your daily work for today. I hope this video has helped you out. Let me know if you need to know some more about the basic information of rigid transformations, and I hope you guys have a great day.